All, I'm Sarah Gogg, and on behalf of my group, I'm going to be presenting to you about the Resource Description Framework, or RDF. So, what is it? In short, Resource Description Framework is a data structure, a data concept that describes information in triples to explicitly tell the computer how information is related. The components of the RDF triple graph are the subject, the predicate, and the object, with the predicate showing the relationship between the subject and the object. It was recommended by the World Wide Web Consortium, W3C, in 1999 to standardize how information is stored and how it is displayed. It was heavily revised in 2004, and it is continued to be revised to this day. It is maintained by W3C, and as I already mentioned, the components of the graph are the subject, predicate, and object. And with these examples below, you can see that the subject and the object are often interchangeable, and that may mean that you have to change the wording or the term that you use in the predicate. So to explain triples, RDF graphs represent how each independent entity and triple can be linked to others. So the graph demonstrates how this works. As you add in more entities, they continue to link without changing the structure of the existing triple links. So in this instance, the employment event, you can build a triple off of that while it is also the object of the previous triple statement with Beth Schrader. This allows one to find information based on the subject or the object of the search and allows you to build continuous links in data graph. So who uses RDF? In short, everyone does. The Library of Congress uses it and is developing a bib frame based on the syntax, based on the structure and the concepts of RDF. It is used across the web and has been incorporated into HTML, and it can also be used as a framework to structure data sets in many different types of programming languages. For the purposes of this video, I will be talking about how it fits into XML, Turtle, and JSON for linking data, also known as JSON LD. So for the XML document, the resource, the subject is defined up here in the About tag. So that is showing a URL, which is one type of URI that you can put in to say what resource you're talking about. And then each subsequent tag in that section is for different properties, different predicates, and then the values of those, which are the objects. So for example, for this album, Empire Burlesque, the artist, which is that predicate, is Bob Dylan. And this is one way of describing all of the different metadata aspects. Now in Turtle, this is a slightly more simplified syntax of how to do an RDF application. This one is done with IRIs. So you on each base tag, you have the resource, the subject, and then you have the predicate and the object below it. And it's just a bit more brief and more efficient way of encoding RDF. Now, JSON is the most elaborate and most detailed of the examples I'll be showing you. It is probably not something you will encounter as much in metadata documents in librarianship. You'll more likely see XML or Turtle. and JSON will primarily be used by web developers or by software engineers. But as you can see here in the this product element, you're defining values for all of the different variables here, which will include the ID of the resource itself, the type, the name, the description. And so are defining kind of strings for those. And then in the context section is where you're actually putting in the URIs, the URLs where you're finding the source of each of those metadata. So for example, the URL where you would find the store, or the URL where you would find the description of the item. Sparkle is the query language that is used for RDF relational databases. Its syntax and semantics are inspired by SQL. So if you have any experience with database design or with SQL databases, you will probably recognize the syntax of Sparkle. It's used to get data from an RDF data collection, answer questions about the RDF dataset. There are 4 different query types: select, ask, construct, and describe. And this example shows you what a select query would return when you're querying a data set of Nobel Prize literature winners and you're wanting both the name and a very specific year, and you want all of the winners for that year. So updates to RDF. The RDF 1.1 version allows RDF graphs to be identified using either an IRI, which is an internationalized resource identifier. It's a version of URI, or a blank node in case you have a missing piece of data somewhere in your data set. 1.1 also includes 3 new serialization formats capable of representing multiple graphs, and literals with language tags now have the data type IRI. These are mostly updates as relating to how coders would code RDF into documents, but you can kind of see on the side here, the serialization formats are essentially like programming languages. So there are just more options for how you can apply RDF in different software environments. Some of the benefits of RDF is that it is a consistent framework with standard syntaxes. It can be used by intelligent software agents, and it's well suited for representing binary relations between 2 resources. So you have the subject and the object, with the predicate showing the relationship between those 2 things. Some of the limitations is that the vocabulary is highly standardized. It can be difficult to choose the most appropriate syntax format for your data set. Also choosing the most appropriate RDF query language based on what kind of database or data graph you have. And it's not great at modeling more than a binary relationship between 2 resources. When you start getting into having more than one subject or more than one object, but it has the same relationship, it can get tricky, not only to make a graph of that, but also to encode it. So some of the current issues with RDF is that it's very complex to understand and to use. There's ongoing work to simplify it and make it more accessible to a broader audience outside of software engineering and data science. Interoperability has also been an issue. RDF and linked data in general is designed to facilitate data merging and interoperability between different institutions, different operating systems, but there have still been some challenges in achieving seamless integration across different systems and different applications. Performance is also a big issue. Processing RDF datasets can be resource intensive, which can impact performance of servers at different institutions. Research is ongoing to kind of optimize that processing, but as it stands right now, uh, it's it requires a certain level of equipment and software that some institutions, specifically smaller libraries, can't really achieve. Uh, so because of this, RDF adoption is not universal yet, and there have been some barriers to widespread implementation, including the need for better tools, better documentation, and more community support. So what are the implications for librarianship? RDF and linked data allow for library records to be shared online with the entire world, not just with other libraries and other cultural heritage institutions, but really with any kind of institution as long as it has a web presence. RDF allows users to search one topic and be linked to related topics by navigating through different subjects and objects through a big RDF graph. RDF enables computers and machines to understand linked items more accurately, which leaves less work for librarians in the future. And RDF is the foundation for BibFrame, which is being developed as the new method of capturing and distributing bibliographic records that will one day maybe be the successor to MARC. And if you want to learn more about RDF, you can check out these references that we use to create this presentation for you. You can check out all of these different URLs. You can find more coding examples, more explanations of RDF and more complicated graphs. I definitely encourage you to look more into it. Thank you so much for watching our presentation, and we hope that you learned about RDF today.